So there are a few miscellaneous items in the nomenclature unit that you do need to know as well. One are some diatomic elements. Diatomic elements. So these are elements where in nature they don't exist as just single atoms. The most common example probably would be oxygen. Most of us know that oxygen's chemical formula is not just O, it's O2. So there's two atoms of oxygen joined together to make what's called a molecule of oxygen. Oxygen is not the only element that does that. The most common diatomic elements are hydrogen, H2, oxygen, O2, fluorine, F2, Br, bromine, Br2, iodine, I2, nitrogen, and chlorine, Cl2. So sometimes we just call those the Hofbrinkel elements. So if you're asked what's the symbol for hydrogen, the element, the symbol would be H. But if you're asked to write the chemical formula for hydrogen, you'd put H2 as the chemical formula. If you see a chemical formula N2, then you'd call that nitrogen. Nitrogen gas is the biggest component in our atmosphere. Now, some people would make a distinction and really be very specific and call this dinitrogen. I won't be doing that. I'll just call it nitrogen. So, diatomic elements. There are also some other elements that have just kind of strange chemical formulas, other elements. Oxygen has more than one form in the atmosphere. While it's usually O2, the Hofbrinkel diatomic form, it also has a form where it's O3, so three oxygen atoms connected together in a small molecule. When it's in the form of O3, though, we don't call it oxygen anymore. We call it now ozone. You may have heard of the ozone layer, which is high up in the stratosphere in our atmosphere and protects us from ultraviolet light. It's just a form of oxygen. Technically, it would be referred to as one allotrope of oxygen. Allotropes are different forms of the same element. So O2 is an allotrope of oxygen, and O3 is an allotrope of oxygen. Another strange one is phosphorus. Phosphorus has a red version of phosphorus and a white version of phosphorus. So phosphorus, in both forms, there's four atoms of phosphorus connected together, but they have different geometries when they're depending on the white or the red version. So phosphorus is P4. Sulfur. Sulfur has several different forms, but the most common one would be S8. And I'm just going to refer to that as sulfur, but some people would actually call it octasulfur, octa for 8. I'm going to just refer to it as sulfur. So those are the weird elements, diatomic elements, the Hofbrinkel elements, and then the other kind of strange ones. And there might be a few others, but these are the ones that I want you to know. Then there are some compounds whose names are not systematic names, at least not systematic in the form that we've been learning so far. So perhaps the most common one would be H2O. If you see H2O, you're not going to say, oh, that's a covalent compound, and then start using prefixes. It's dihydrogen monoxide. No, you're just going to call that water. Okay, so if you see H2O, its name is water. Another one would be NH3, whose name is just ammonia. We wouldn't say nitrogen trihydride. We would just say ammonia. Now, there are a few organic molecules that we'll study later in the organic chemistry unit, and there actually is a systematic way to name them, but it's not the same as what we've been learning. So we're just going to look at two or three of those here, and I'm just going to ask you to know them. So for example, CH4, this is the gas that comes out of our Bunsen burner nozzles on our desktops in the lab, and that's methane. Methane. Okay, there are a whole bunch of different hydrocarbons, molecules made of carbon and hydrogen, with similar names. There's ethane and propane and butane, etc. Methane is the simplest one with just one carbon, CH4. If you take away one of those hydrogens in the methane, so now we have CH3, and then you add on what's called a hydroxyl group. It's called a hydroxyl group. It's very similar to a hydroxide ion. It looks the same, OH, but it's not a negatively charged ion. This whole thing is covalently bonded. It's a molecular compound, so this is called methanol, which is a type of alcohol. So it comes from methane, where you've removed a hydrogen and you've added an alcohol group, the hydroxyl group, the OH. That's the alcohol we used in grade 9 science. It's used as windshield wiper fluid, several other uses. You don't want to drink methanol. It's the one that's poisonous. Well, most alcohols are poisonous. This one will make you go blind and will kill you if you drink it in any large amounts. The alcohol that people drink, if you drink any type of alcohol, it's going to be ethanol. So let me just write its name down here, ethanol. So if methanol comes from methane, well then ethanol comes from ethane, and it has two carbons instead of one. So the formula is C2H5, and then the OH, which is the clue that it's an alcohol. So C2H5OH is ethanol. And then one other one, perhaps we have very common in biology classes, a form of sugar, C6H12O6. This is a simple sugar, a monosaccharide, if you've studied some biochemistry. There's different versions, but this one we're going to call glucose. So in the chemical reaction for photosynthesis, plants take carbon dioxide and water, and they synthesize glucose and oxygen with the help of sunlight. If you take two of those glucose molecules and join them together, you get what's called a disaccharide. So two of these simpler units join together. But in order to join them together, water molecule has to come out of the two. So the simplest example, the most common one, is sucrose. This is the type of sugar that we would have in your kitchen if you're putting sugar in your coffee, for example, or in your tea. So sucrose is sometimes called table sugar. It's two glucose molecules minus a water molecule. So instead of 6 carbons, we're going to have 12 carbons. Instead of 12 hydrogens, now be careful, you double it because there's 2 glucoses, so you're thinking H24, but then you had to remove a water, so you had to remove an H2O. So instead of 24, you'll have 22 H's. And then O, you'd want to think O12, but you had to remove a water, so you removed 1 oxygen. So instead of O12, it's O11. So it's 2 glucose molecules joined together minus a water molecule. I think that's all of there are a bunch of other molecules that are not necessarily standard nomenclature, and we might see a few of them on our worksheets, but these are the ones I'd like you to know for sure going forward. Okay, so these elements that are diatomic, those are very common. Make sure you know the Hofbrinkel elements. These other ones, ozone, phosphorus, sulfur, they're not quite as common, but we will see them a lot. And then these compounds with these non-systematic names. You'll probably encounter them quite a bit in our worksheets and in our next couple of units.